Hello everyone, today let's solve the problem number 19, remove nth node from the end of the list. So let's see what the question states here. We are given the head of the linked list, see here. We are given the head of the linked list here, 1, 2, 3, 4, 5. So for this particular example, so here 1, here we have 1, 2, the elements within the head of the linked list, right? So we are given the head of the linked list. We have to remove the nth node from the end of the list and return its head. We have to remove the nth node. Here see, n we have been given 2, right? N we have been given 2. So they have said one more thing. What they have said, remove the nth node from the end of the list and return its head, not from the beginning. We have to consider nth node from the end of the list. So here in this case, for the first example, this will be 1. We have to remove the nth node from the end of the list, right? So this will be 4, this will be 5. When n we have been given 2, we have to remove this element, right? Fourth element, and we have to return the head. This remains same after removing the this one, the element that is present at the third index, this one I'm speaking of. So this remains 1, 2, 3 and 5. Sorry, 1, 2, 3 and 5. So this one 4 we don't have, right? So 1, 2, 3 and 5. So this is the output basically. So this one node I wanted to represent this one in the form of node. This is fine, right? 1, 2, 3, 5, right? This is fine. So here the output that we got here is 1, 2, 3, 5. This one we need to return, right? So that's what the question states. We have been given the head of the linked list. We have to remove the nth node from the end of the list and we have to return its head. Simple, right? So let's go with the second example here. Head we have 1, n equals 1. Head we have only one element. So n equals 1 we have been given here. So after removing that element, we get the output empty, right? Nothing is left in the list. So we have to return the empty list here. So the third one is we have head 1, 2, and then we have been given 1 from the end. We will remove this one, first one, 2, and we are left with the element 1. That's it. Basically, that number or that value itself will be returning within the list. Nothing but the 1 here in this case. Output will be 1. So I hope the question part is completely clear. They have given us wonderful examples just for the sake of understanding here, right? So now, as we are familiar with the question, so let's discuss the approach first, followed by the complexities, and then let's write the code. So approach first. So just before hopping into the approach part, I just want to tell you one thing. So just give me a second here. So let's consider the same first example for the approach, right? So before that, we will be going with the linked list, right? So this is a question based on the list. We'll be making use of the linked list data structures, the operations that the linked list provides in the Java. That will be making use of to write the code within the code, right? So I hope this part is clear. Let's come to the approach part here. Let's consider the same first example here. Let's consider the same first example here. First, what we'll do here, we will add the dummy node. First, we will add the dummy node. 1, 2, 3, 4, 5 we have. So let me consider this one dummy. Then comes 1, then comes 2, then comes 3, then comes 4, and then comes 5. Right, 1, 2, 3, 4, 5 are the elements that we have in the list within the example one. This one we are considering, right? So now we will initialize 2 pointers, first and second to dummy. So what we'll do, we'll initialize, suppose we consider this one first and this one second, right? So these are the 2 pointers we'll be considering, and this one we will initialize to the dummy node. So most of the problems when we are dealing with the linked list, basically we'll be making use of the dummy man. So how within the trees we can, whenever we're solving the trees problem, we can either solve with the BFS or the DFS. The same thing goes with the linked list as well for most of the problems. For not will not be considering dummy for all the problems, but for most of the problems we will be considering dummy. So it will be easier to solve the problem when we consider the dummy node. Just keep this in mind, right? So let's move on with the further things. We have initialized the fast and slow pointers, first and second pointers, sorry, here this one to the dummy node. So we are done with the second step. Next step, what we'll do, we'll move the first pointer n plus 1 to 3. So this one to the, we'll move this one to the 3. So as this is one indexed, what we will do, so we have been given n equals 2. We have been given n equals to 2. As this is one indexed, we are considering the removing the element from the end, right? So we are considering removing the element from end. So this will be 1, 2, 3, 4 and 5. N we have been given 2. N we have been given 2. So what we will do here, we will move the first pointer from dummy to this one, dummy to n plus 1. N is nothing but we have 2, n plus 1 is nothing but 3, right? So we will move the this one first pointer to n plus 1 nothing but 3, and this one remains same. The second pointer remains at dummy itself, right? So this part, I hope this part is completely clear, right? This will be the third step. And at the fourth step, what we will do, we will move both pointers one step at a time until the first reaches end, until the first reaches end. So next step, first we will move first from 3 to 4. Now first will be at the 4, and the this one second will be at the 1. Second will be at the 1, right? So next part, what we will do, we will move the first to here, this one. Now the first will be at 5, and the second will be at the 2. Second will be at the 2. Now the second is at the 2 and the first is at the 5, right? So finally we'll move this one 3. We are left with nothing here. 5 is the last element, right? So if we move the first pointer, it will be null. Further, we don't have any this one. This will be null, and the second comes to 3, and the second comes to 3 here, and the second comes to 3, right? So here in this case, second is at the 3, first is pointing to the null, right? So we will delete the nth node from the end. Now we will delete the nth node from the end, meaning second is right before the node to be deleted. Node with the value 4. Node with the value 4 I'm speaking of. We are at the this one, node 3. Second, we will move this second to the this one. What do we call this one, right? The last step. We'll move this one from 2 to 3. Second stays here, and first to null, the last part. So now first is at the null, and second is at the this one. What do we call, second is at the 3. Second is at the 3. Now we will delete the nth node from the end, meaning second is right before the node to be deleted, right before the node to be deleted, right? Right, yeah, node to be deleted, meaning node with the value 4. Node with the value 4, right? So we, what we will do, we will skip this one by second dot next equals second dot next dot next. So that's what we'll be doing in the code. That's what we'll be doing in the code, right? Now after skipping, so the updated list, so second of what I'm trying to say here is, after moving this one, after this steps, first is at the null and second is at the 3. So whenever we perform these steps, whenever we perform these steps, the element that need to be deleted, the element that need to be deleted will be right before the node, will be at its right, will be at its right. Basically that's what I want to say here. We are at the 3, the element will be always at the right of the second node, this one. So what we will do, we will skip the second dot next by making use of second dot next equals second dot next. By making use of second, we will assign this one to the second dot next to second dot next, meaning we are skipping the right one just next to the second, right? So this way we can do, right? Second dot next equals second dot next. So we are entirely skipping this one, we are deleting this one, we are skipping this one, means now we have the elements, now we have the elements d1 2 3 and 5, d1 2 3 and 5, d1 2 3 and 5, right? So these are the nodes we have in the linked list, right, including the dummy d1 2 3 and 5, right? So finally we will return the dummy dot next, because we have to ignore dummy. We just took this one because it will be easier for us to solve the problem. So at the end we will return dummy dot next, not the dummy. So not from the dummy, basically we will return dummy dot next. We just took the dummy node because it will be easier for us to solve the problem. Here in this case we will return dummy dot next. This leads to 1 2 3 and 4, 1 2 3 and 5. Basically that's what the answer we got here, 1 2 3 5 as the output. So the output that we got here is 1 2 3 and 5, which is equivalent to the output that they have mentioned for the example 1. Example 1. I hope this part is completely clear. I hope this part is completely clear. Very easy to understand, right? So uh, at the end, what we'll do, we will return 1 2 3 5. So the output that we got here is equivalent to the output that they have given for the example 1. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So this is completely based on, again, this is completely based on the tortoise and hare algorithms. This is based on the Freud's algorithm, right? So now what we are doing here, now what we will be doing here, let's do one thing. Let's skip this one. Let's do one thing. Let's discuss the complexities before writing the code, and then after discussing the complexities, let's write the code. So what will be the time complexity for the code that we'll be writing in the future here? So the time complexity would be big of SZ. What is the time complexity here? Big O of SZ. When I say the time complexity is big O of SZ, we are traversing the list once with the 2 pointers. We are traversing the entire list once with the 2 pointers. One is first and second pointers, right? That's what we considered in the approach. So we will be traversing the list once entirely through the 2 pointers. I hope this part is clear. What would be the space complexity? Space complexity would be big of 1. So space complexity is big of 1 here, because we are not making use of any extra space here, right? We are just making use of the 2 pointers itself. We are just making use of the 2 pointers only. So the space complexity would be big of 1. So the time complexity would be big of SZ, uh, and the space complexity would be big of 1 for the code that we'll be writing in the future, right? So now we are completely done with the this one, what do we call, approach as well as the complexities, right? So the time complexity would be big of SZ for the code that we'll be writing in the future, and the space complexity would be big of 1. And we have successfully discussed the approach part as well. Now as we are completely familiar with the approach and the this one, what do we call, complexities, we are good to write the code. Let's start writing the code. So first thing is, accordingly with the approach, what we need to do here, let's create the dummy node, right? Just to simplify the edge cases, like deleting head, those things, right? So let's create the dummy node. It will be easier for us to solve the problems when we consider the dummy node. Suppose in certain questions they might strictly ask us not to make use of the dummy node, not to make use of the dummy node. That scenario may come in the future as well, right? So that might happen as well. They might have strictly asked in the question not to make use of the dummy node. These kind of questions will be asked, right? So most of the problems would be basically this one. It will be really helpful when we make use of the dummy node, right? It is easily solvable. That is the reason we make use of the dummy node usually. Same thing goes with this one as well, right? In the trees, while solving the problems on the trees, basically usually we go with the BFS or the DFS with the recursion. It can be solved with the iteration and the other parts as well, other this thing as well, but it will be very easier to solve the problem with the recursion, either with the BFS or the DFS. It is very easy to solve the problem with the recursion, right? So same thing goes with the linked list as well. Most of the problems involve dummy node. Most of the problem involve dummy node. Not every problem involves it, but most of them do, right? That's what I wanted to say, right? So I hope this part is clear. First step here, according to the approach, let's create the dummy node to simplify the edge cases, like deleting head, right? So here on this case, I'll just go with list node. Let me make use of the dummy, and let me go with new list node of here 0. This is fine. We are assigning that one to the first this one index, right? So here on this case, dummy dot next, this one points to the head. Quite obviously, dummy itself says that it is dummy, so dummy dot next has to be the head, right? So finally in the return, we will ignore the dummy. We'll ignore the dummy and we'll assign the dummy dot next, right? So we'll just return the dummy dot next from dummy dot next, basically, right? So here we are done with the first step. So what was the next step in the this one approach? After creating the dummy node, we have to initialize the 2 pointers starting from the dummy. Basically, let's do that. I'll just go with list node first equals dummy, and the second thing here is list node. Let me assign the second to dummy as well. So We are done with the initialization of the two pointers that is starting from the dummy. So after the second step, if you remember the third step, we have to move the first pointer n plus 1 steps. Means we moved the first pointer to the n plus 1. Nothing but in our example, n was given 2. N was given 2. So we moved the first pointer which was present at the dummy basically, which was present at the dummy. Just give me a second here. Yeah, dummy here we moved from dummy to n plus 1. N was at 2. N is given 2 here in this case, right? We moved to 3 directly. We moved to 3 directly because we are moving n plus 1. Means we are moving the first pointer n plus 1 steps ahead to maintain the gap. So let me do one thing here. Let me delete this one, right? Let me delete this one. So we are moving the first pointer n plus 1 steps ahead to maintain the gap here. Let's go with the simple for loop here. This will be int I equals 0, I less than or equal to n I plus plus. So this is for loop. Within the for loop, what we'll do, we will assign the first to first dot next. We will assign the first to first dot next. This is fine. So let me come out of this for loop and let's move on with the further things. If you remember the this one, what do we call? So the last step was we moved the first pointer to n plus 1 steps. I had to maintain the gap. We know this one from the approach. After this one, what we did in the approach, basically we moved both the pointers until the first reaches the end, until the first pointer reached till this one 5, right? So this one until the first pointer reached end means until null. So null, the first pointer, until we will move the first pointer until null basically, where we don't have the this one elements left in the list, right? Until that one we have to move. So if you remember, that's what we did, right? So same thing, we have to articulate that one in the form of code here. So I'll just go with while first not equal to null. Then what we need to do, let's assign first to first dot next. Let's assign first to first dot next and second to this one second dot next. So this one second to second dot next. This is fine. So let me come out of this one entirely. Let's move to the next step. Next step. So what we did after moving both the pointers by until the first reaches the end. After doing this step, after end of this step, if you remember, we have to skip the nth node from the end. We have to skip the here comes the basically the first node, the second node would be here, and every time we need to remove the next node, this the node next to the second node. After performing the previous step, this step we have to remove the next node to the second pointer. Means we can write that one in the form of code like this: second dot next. We have to skip this one, right? We can just assign this one to second dot next. So we are skipping this one. We are assigning this one from 4 to 5. After doing this step, we are assigning this one from 4 to 5, meaning so the answer will be every time present next to the second pointer. After this step I'm speaking of, right? Next to the second pointer. So we can assign second dot next to second dot next means we are skipping this one entirely and we are just considering this node, right? So this will be output will be 1 2 3 4, 1 2 3 5, sorry, 1 2 3 5, right? So this one we can write it in this way: second dot next to second dot next. So what we are doing in simple terms, we are just skipping this one, the right node, the node which is present right to the second node, second pointer, sorry. Yeah, so we can just write here second dot next to second dot dot next. This is fine. So let's come to the final step here. Let's come to the final step here. We have to return the new head. Meaning dummy dot next. We have to ignore the dummy and we have to start the this one. We have to return the head from this element, right? So initially we are considering the dummy element. So we have to ignore this one. So head we need to return dummy from the dummy dot next from or from the first element, nothing but one in this case. So I'll just give here return dummy.next. So we are done with the code. Let me format the code once and let me hit the run button. Let me hit the run button. So here what we have here in this case. So yeah, n is I have given this one n small n here, right? Line number 3. So let me make this one capital. So now this has to work. Let's see. So we have just articulated the same thing in the form of code. Whatever we discussed in the approach, we articulated the same thing in the form of code step by step, right? That's what we do in the every problem. Same thing goes here as well. So here in this case, you can see the sample test cases got passed. Means let me hit the submit button now. So I hope this works for all the test cases as well. Let's see. So you can clearly see here, all the test cases are getting passed. Means the code works absolutely correct in this case. The code works absolutely correct in this case, right? So here you can clearly see, here you can clearly see the code got I mean the code got accepted, right? Means the all the test cases are getting passed. So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.